On behalf of excuse me, RBCS and software test professionals, we welcome everyone today to this webinar on balancing quality within constraints. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been a pioneer and leader in quality hardware and software testing. We have offices in the United States and partners around the world. We deliver insight and confidence to our clients. We help them get quality software and hardware products to market on time and with a measurable return on investment. RBCS has a team of international consultants, and we deliver customized training, consulting, and outsourcing services for companies that are looking to improve their testing and quality assurance practices. We have helped hundreds of companies reduce their development and support costs while assuring the best quality products are delivered to their customers. I am author of Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and 3, Foundations of Software Testing, Critical Testing Processes, Managing the Testing Process, and Fundamentos de Pruebas de Software, which is the first book on the ISTQB certification program in Spanish and the first book in any language aligned with the 2011 Foundation syllabus. I am also the author of 2 upcoming ebooks. One of those is called Testing Metrics, Measuring Product, Process, and Project Quality, and the other is Improving the Testing Process, a Value-Based Approach to Assessing and Enhancing Testing Maturity. I hold a degree in Computer Science and Engineering from UCLA, and I am past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. And congratulations to the new president of the American Software Testing Qualifications Board, Judy McKay, by the way. RBCS is presenting this webinar in partnership with Software Test Professionals. The SDP Spring 2012 Conference is coming up March 27th through 29th in New Orleans, Louisiana, and what a great town that is if you've never been there. The early registration discount ends tomorrow, so don't miss out on your chance to save $400. Visit www.stpcon.com for more details. I'll be speaking at their conference, so I hope to see you there. Attendance at today's webinar does earn PMI PDUs. I would like to thank Michael Lindhorst for reviewing the materials for PDU status. You can visit www.pmi.org to claim the PDUs. Use code MQ100. That's PMI PDU code MQ100. RBCS's provider ID is 2986. Please note that PDUs are available for live webinar attendance only. Now, before we start the presentation, some housekeeping notes. If you have any questions at any point, you can submit them whenever. Please note that I do not look at the questions until the Q&A session at the end, though. So please don't submit a question and then like in 5 minutes, and then 5 minutes after that be saying, "Well, how come he hasn't answered my question yet?" Well, it's because I haven't seen it. You do not need to ask for copies of the presentation. The presentation is posted. It's at rbcs-us.com, and then select the Resources tab in the upper middle of that home page and go down to Library, and then navigate to the Basic Library, and you will find a PDF version of the slides at the bottom of the Basic Library. Now, there is also no need to ask about how to register for the e-learning. The free e-learning. You are automatically registered simply by the fact that you are now attending this webinar. Check your email over the next couple days and watch the spam filter and make sure that any notifications don't get lost there. You do have a limited time to respond if you win. Now, if you're having technical difficulties, go to webinar support is the place to go, Citrix support. Just a few tips. Sometimes there are browser compatibility problems, so if you're trying with one browser and not getting through, then try with another, and that may very well work. Audio settings, if the voice is very faint, you might go and look at your audio settings, your operating system audio settings, and that can often fix the problem. The other thing that you wouldn't be hearing this right now if you have this problem is company firewalls. Company firewalls can prevent the downloading of the Citrix software, which means you can't get on at all, and there's not much you can do about that other than to get the company to lift that particular prohibition in their firewall, or use a home or personally owned device. more and more people are bringing iPads and so forth to work, and I'm not sure if an iPad actually does work, but perhaps it does. If any of you have tried it and it works, let me know. Absolute last desperate case scenario here is download the slides from the basic library, as I said, and then just use the telephone to connect rather than voice over IP, and you could follow along with the presentation, or just listen to the recorded presentation later if you just can't get it to work. But most people, I think, are able to resolve the problems. So with that in the way, I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for profit company. So today's presentation is on balancing quality within other constraints. So everybody manages projects within constraints. There are always constraints, but some people do a better job of managing those constraints in the way they relate to quality, and that's what we'll look at today, assuming my slide advances. So it would be great to live in a world where there weren't constraints, right? You just had all the time, all the resources. Everybody wanted to have perfect software and would spend as much time as it took to make that happen. But that's not really something that you see. Certainly I've never seen it, never worked in an organization, never consulted with an organization, never spoken with anybody who's worked in an organization that did things that way. There's always constraints. And basically you got 4 variables on any project that you get to play around with, right? There's schedule, budget, features, and quality. Now, the thing is that those exist in a balance, which means that there are trade-offs. You can't just arbitrarily say, I want perfect quality, and I want it cheap, and I want it fast, and I want all these new features, because that won't work. Now, what can happen here is, instead of balancing, people take quality for granted and just say, well, here's the delivery date, and here's how much we're ready to spend, and here's the features we want. And then you say, well, yeah, but what about the quality? Well, of course it's got to have quality. Well, if you haven't thought about it, then maybe that's not going to happen. In fact, that's almost certainly not going to happen without some sort of deliberate approach to balancing the constraints and so forth. You're not going to get this right. I mean, I've never seen an organization do that without putting a lot of energy into figuring out how to get that balance. So let's look at that, how we can get that balance right. First, I just want to be clear about the trade-off here and what I'm talking about. You think about the typical project. Let me get a highlighter up here, spotlight. Okay, so typical project, what do we start off with? Well, we're going to define some set of features that we want, right? And then this would be true whether we're talking about Agile or we're talking about sequential lifecycle. There's some sort of wish list of stuff we want to do. How documented that wish list is kind of beside the point, but there's some idea of this is what we want. This is why we're going to have a project, because without that, you've got no rationale for a project. Okay, and then the schedule is often determined. Now, again, the sequential and Agile, this will be a little different in terms of what the schedule looks like, but there's still going to be some concept of here's what we're building and here's when it will be ready. And cost is then the next thing of, okay, here's how many resources we've currently got, and here's how many additional resources we can get, and there you go. Now, sometimes people say, well, okay, this is our project plan here. Well, no, because basically you can see by this triangle I'm drawing here that once you've defined a set of features, selected a scheduled time, and selected a cost, your quality is going to be whatever your software engineering process's capability is within those constraints. Now, I'm not saying that the process can't be improved over time. The software engineering process improved, and its ability to produce better quality within the same set of constraints cannot be changed. That of course can happen, does happen. We help our clients do that in a lot of engagements, but it's not just going to happen. I've seen a number of situations where people just did this wishful thinking assumption of, this time we'll get it right. This time things will go better. Well, no, I mean, your process is what your process is, and without some sort of deliberate attempt to change the process, which is not what we're really talking about here, you're going to get whatever level of quality your process is capable of producing. So that's where the trade-off comes from. That's the essence of the problem. Now, life is of course full of trade-offs, right? So the quality schedule trade-off. What's typical examples of this? Finding a bunch of bugs late in the project, and I'm sure a lot of you have been there. When that happens, your testing costs go up, the risk of project delay go up, and features themselves are sometimes thrown overboard to try to hold the schedule. So if there's not a way of dealing with quality throughout the schedule, as opposed to just waiting to the end and trying to test quality into the system by grinding the bugs out, then the ultimate schedule quality feature mix that you get is going to be pretty hard to predict. And there's also the features versus schedule stuff that can happen. As I said, if you don't have good estimates, features can get dropped at the end of the project, and those might be the wrong features. They might be the ones that are more important to the customers. This is maybe more common with a sequential lifecycle model than with an agile lifecycle model, because theoretically in an agile lifecycle model, you're going to start by building the more important features. So if you were to run out of time on the whole set of features, at least the most important ones would be built. But still, the fact that you didn't get everything done that you wanted to get done is not ideal, of course. And also the right bugs have to get fixed, and this can be a real problem too. If the bug triage process breaks down and you're not managing the bugs properly, the prioritization isn't right, and bugs get fixed, but maybe not the right bugs, and you end up going to the market with something less than you would have liked. So planning and estimation is something that can help you try to get some of this uncertainty off the table in advance. But there's always going to be some amount of the known unknowns and the unknown unknowns that are going to be out there and can pop up and nail you. So having a good plan, having a good estimate by itself, those things are not enough. So what else do we need to have a good quality balance? So here are 5 things that I would say are essential elements of achieving a good balance of quality within constraints. There's patterns that I've observed, companies that I've worked at, and clients I've consulted with, and so forth. So it's the 5 here in no particular order: shared vision, discipline management, quality being built in and bugs being ground out throughout the life cycle, focused testing, not random testing, not just testing by wandering around, and sending the right message to everybody so that there's a direction. So let's take a look at these. So the shared vision of a product. Let's start off with this joke, aphorism, whatever you want to call it. The camel is a horse designed by a committee. It kind of doesn't look quite as elegant as a horse does. And I suppose if you're in the desert, you might be perfectly happy to be on a camel, but it's not certainly not the most elegant looking solution to the transportation problem. Now, that same thing can happen with software when there's no shared vision of what's to be built. Now, it's not that diverse perspectives are an issue. I'm not saying groupthink is essential, or there has to be a single person who makes all the decisions and everybody else just follows. That's not what I'm saying. What I'm saying is that if there's no eventual coalescence about what the product is and what it's supposed to do, then you're going to get people pulling in a different direction. And that shared vision also means addressing this question of budget, schedule, feature, quality. What are we trying to achieve in each of these areas, and how do we strike a proper balance? If we have to make a trade-off between those at some point, which is the most important thing? Because to the extent that you don't have shared objectives and a shared perspective on how to make trade-offs, you can't succeed. Now that sounds harsh, but think about it. A true success is a program or a project or a product where all the stakeholders are satisfied with the outcome. Now, they're not necessarily thinking, "Oh, that was perfect." But they are satisfied. They're like, "Yeah, that turned out well." If you have people pulling in all sorts of different directions, well, somebody's going to get outpulled. There are going to be some set of people who are going to, not see things turn out the way that they would have liked. Maybe nobody sees things turn out the way they would like, but even if some do, some don't. And so the endeavor really is not successful because, in the eyes of one or more of the stakeholders, it did not achieve what it should have achieved. So let's look at an example of where that shared vision is working. The Apple iPhone, iPad, iPod product line; those have been very, very successful, and had all sorts of interesting spin-offs as well, the spin-offs that are consistent with the vision of the thing. So you think of the iTunes and iPod, right? So now there's this whole music distribution channel thing that came out of the iPod as sort of a byproduct. The iPhone has changed what people's thoughts are in terms of what the capability of a smartphone should be. So what's going on there? How's these relatively pedestrian objects, that have been around in one form or another in the past, how did these things manage to become sort of transformational? Well, everybody's got their own take on the Apple success story, but certainly I think we'd all probably agree, and those looking at it, to say that there has been this very uncompromising commitment to certain key design and quality attributes. That there's just something about those products that just is unmistakably them, and in a good way. Now, I'm not here saying, "Oh, Apple is perfect. Apple doesn't make mistakes." Those products do definitely have bugs. I have cursed at my iPhone probably as many times as I cursed at my Windows PC, and often for the same kinds of misbehavior. So, the iPhone and the iPads, we've seen that there are compatibility issues, and some of those are compatibility issues by design. Others are, I think, just more by I don't know, neglect, I guess, not making it a priority. There are reliability issues. I certainly can manage to crash my iPhone fairly regularly, though it's not crashed in the middle of a phone call, so this is good on that part. And maintenance can be a little bit sketchy. There's sort of a if it's more than 2 years old, you should just buy a new one kind of thing going on there. I don't know if it's planned obsolescence or if it's just that the cool people get to work on the cool stuff, which is the new stuff. I don't know how that happens, but they're not perfect. But regardless of that shared vision of the product and the product line is clearly there, and they can do a lot of really nice things. They definitely are each in their own way game changers of what were at that point established types of products. Certainly Apple didn't invent the smartphone, but now their smartphone is anybody's brand of smartphone is going to be measured against capabilities that the Apple iPhone has. Apple didn't invent the personal portable music device either, but the iPod definitely has changed the way people think about that. Now, bad example of lack of shared vision. This one's courtesy of, for those of us in the United States, our tax dollars finance this one. So this makes the story extra nice. So in the 1990s, the United States Federal Bureau of Investigation was going to try to make all of their office systems electronic. They were going to go from paper. Everything was going to be automated, and there was about a 10-year period in this project that's just what dragged on and on and on. And other than automate more, there really wasn't a shared vision for this project. Apparently, it was just go off and make stuff more automated, and so it just it had the Christmas tree problem, which if you've never heard that before, basically that's if you put a Christmas tree up and then just invite people in, everybody will hang their own personal favorite ornament on the thing, and if you don't put any sort of limit on that, eventually the limbs start breaking off the Christmas tree because so many ornaments get hung on it. Well, that's sort of what happened. Is it features and scope changes were ongoing, and this was a real bonanza for some of the consulting companies that were working on it, the change orders and so forth. But as far as value to the taxpayer, it ended up being less than zero because it was a distraction to the FBI, and it was ultimately canceled without any deliverable. So if you don't know where you're going, any road will get you there, as the saying goes. But it turns out that if you don't know where you're going, any road will get you there, but where you're going is nowhere. Now, discipline management. This is another key element here. So know what features to leave out as well as what features to include. That's avoid that Christmas tree problem. Being able to say no. No, we're not going to do that. No, that can't happen. No, we can't deliver by that date with this much content. If you want to drop some content, we can do that. And there has to be the ability to say no, and not in an unpleasant way. Not like I'm going to ruin your day and this is going to be fun for me. But no, sorry, we can't do that. We want to succeed together rather than fail together. Discipline management is also about knowing what quality attributes matter to the users and customers. What's important? Is performance important? Is security important? Is usability important? Is reliability important? Is compatibility important? Backwards compatibility with previous versions, that important? These are things that people need to talk about, and that's part of discipline management. Know what matters and what doesn't matter. Sorry, there was a beep there, which kind of made me wonder if I was having a problem, but it doesn't look like it is. Now, another part of discipline management is understanding what part of the software process what parts are essential to have a quality outcome, a quality deliverable, and stick with those. It's not unusual when we're consulting with clients to hear stories about, well, at the beginning of the project, the plan was we were going to do code reviews for all the code, and we were going to have requirements reviews for the requirements, and we're going to do complete unit testing, and the developers were going to get 100% statement and branch coverage on their unit testing, and we were going to have careful component integration testing, and blah blah blah. And then, well, what happened? Well, we committed to twice as many features as we should have, so we started shortcutting the quality stuff and just focusing on getting the features done, and then we had a big explosion of bugs in the testing at the end. Surprise, surprise. So that's when that happens, when those things that organizations know they should do from a quality point of view, when those things get dropped because of other pressures, then you're dealing with a management discipline issue. There's also certain, maturity. It's not just management. It's really throughout the organization, but it has to be instilled by management. This idea that this quality is everybody's job. Now, I think people outside of testing, they get frustrated when they hear a test manager or test consultant like me say that, because it sounds like evasion. Like, well, don't blame us if the quality is crap because we just tested it. It did that can come across as I say, evasive or not taking responsibility. But I mean, it is true that you can do a very good job of testing and still not have a particularly good product. I mean, you think of, let's say you go into final phase of testing, system integration test, let's say it is, or system test. And let's say that your defect detection effectiveness of your testing organization is 95%, which is pretty good. And that's a pretty good number based on our metrics. Well, if you deliver that team 1,000 defects, you're still going to have 50 defects getting out of that process, escaping from that process. So, that could be a relatively large number of defects. And contrast that with you've got a team that's 90% defect detection effectiveness, and they're only delivered 100 defects. Well, then you only have 10 defects get out. So, you can't judge the effectiveness of the testing by the raw quality of the result. The testing can be very good, but if what's fed into it is very bad, then there are limits on how much change can be accomplished by that. And that's what I mean when I say everybody has a role to play. This is not about evasion. This is about just understanding the realities that there is a certain defect detection capability in any testing process, and that's some percentage of the number of defects that you're handed. So that's part of the discipline is making sure that you understand that there aren't any quality magic wands or magic pixie dust anywhere. It's just hard work involved, and also listening to people, including the test manager, is another sign of a disciplined management team. I've worked with managers that were development managers and project managers and so forth that were very good at listening to me as a test manager or my clients' test managers, and could sit and listen, and you could tell that they sometimes were uncomfortable. Like, God, I really wish I weren't hearing what I'm hearing, but they were going to say, these are the facts. This person's on my side. This person's here to help me. That's disciplined management. When people engage in self-selection of what they're going to listen to based on what they want to hear, that's just not a very mature way of managing projects. Avoiding uncomfortable facts does not make them go away. So let's go at an example of discipline. So IBM's Xeos, their mainframe operating system, which grew out of their OS 360 project back in the 1960s. So this code, has been around a while, and it's continued to mature over the past years. And you might say, it's Xeos, a mainframe, who cares, COBOL, that stuff doesn't matter to me. Well, okay, but consider this: 90% of Fortune 500 companies use Xeos for their core business. So that's a big number. If you think about how much of the world's it wouldn't be domestic product or national product, but just the world's economy flows through 90% of the Fortune 500 companies. There's a lot of money being managed by those machines, and it's not an accident because they work. So it makes sense to look at what Fred Brooks and his team did, and fortunately, Fred Brooks wrote a great book based on his experience with the OS 360 project called The Mythical Man Month. And if you are a manager, test manager, development manager, project manager, any manager in the IT business, highly recommend this book. Now you might say, geez, what a dinosaur, it's 1960s, what could this possibly have to do with me? Well, you'll be surprised. If you read it, you as a manager, I can promise you will see things and say, God, I've been there, I know exactly what he's talking about, I've seen that happen before. There's maybe 10 pages in there, some of which has to do with things like managing core memory that, you can just say, okay, well, that doesn't apply anymore. Thank God that we don't have to deal with that constraint. But if you think about it, there's probably another constraint, another issue that's come up that's technology specific that would apply still. So if you sort of take the meta picture of what he's talking about, this is a lot of good stuff in there. So what did Brooks and his team do? How did they achieve the success of building this code that's still, running much of the world's economy 40 years later, they had requirements reviews, and not just send it out to one other business analyst or requirements engineer and have them look at it, kind of requirements and reviews. No, what they did was they had independent test team set up, and remember, this is 1960s, and these independent testers were involved in the requirements reviews. So, how good is that? They had unit testing and system testing, and these were separate things done by separate people. The developers unit testing and independent test team doing the system testing. We've got multiple levels of testing. There was a unified design, so that's that shared vision. There's Brooks's concept of the chief programmer teams. I think if you were to go back and look at that description and stack that up against how maybe a modern Scrum team looks, you might say, "Wow, geez, there's some similarities there. There's some interesting parallels." And they definitely knew which quality characteristics were important for their customers. They knew what they needed to focus on. Now, okay, for those of you who are still unconvinced and still sitting there going, IBM, dinosaurs, okay, well, no, this stuff still works. This stuff still applies. We have a client, they're in the banking business, and they follow many of these practices. They have requirements reviews that are led by the test team, organized by the test team as well, as a service, by the way, to the project teams. They do them. Unit testing and component integration testing is done by the developers. The system testing and system integration testing are done by independent test groups, so you get the separation of duties. They have key quality characteristics that they identify at the beginning of each project. Here's what's important from a performance, reliability, etc. perspective. And this approach is able to deliver very innovative technologies for the bank, which is one of their strategic goals. They have as a way of differentiating themselves from their competitors, being first in the market with new and interesting technologies. But they don't compromise quality to do that. They also manage to deliver very, very high quality. Their defect detection effectiveness of their system integration test team fluctuates between 99 and 99.9%, which is phenomenally good. Now, quality throughout the life cycle, bugs being removed throughout the life cycle. This is another key element here. And I'm sure many of you, if you've been in the business anywhere near as long as I have, you've been through one of these quality crisis projects where shortcut after shortcut occurred, and there was no thinking about quality. What are we going to do about quality until all of a sudden the very end, and you just get this enormous crisis of, oh my God, look at all the bugs. So as I said before, this has to be a whole team kind of approach of here's how we're going to build a quality product, and everybody has to be part of that. And there does need to be this emphasis on any work product that's being produced. It's not just like, yeah, it's done, it's close enough, who cares, there ain't any bugs in it, let the testers get them out later. But a real sort of craftsmanship, a pride of work of, I'm going to build stuff that's good, while at the same time recognizing, well, I'm going to try to build stuff that's good, there's going to be bugs, so let's get those bugs out earlier rather than later. Now that concept of getting bugs out earlier rather than later, so that's got a fancy name, a phase containment, it basically says try to remove bugs as close as possible to the point of introduction, because the longer a bug is around, the higher its cost of removal is going to be. And since cost of removal is often associated with effort, and then the higher the effort, the more the risk from a schedule point of view. And this is true whether we're talking about sequential life cycles, we're talking about iterative life cycles. We've got plenty of clients in they're doing Agile, and I have heard from some of those that we're having sort of the more troublesome Agile experiences about, that's schedule is everything until we get into the end of the sprint. And then all the testing has to be done by the end of the sprint, even though everything slipped. And, it ends up being this big crunch. I had one client say they were on 4-week sprints, and every 4 weeks, the testers had to spend Saturday and Sunday in the office testing. Just the testers, by the way, not the developers who weren't there. That's really not a particularly agile approach. Obviously, from a sustainable workload perspective, that's not good at all. So these things can happen. So what you want to do is say, no, let's think about this stuff throughout the entire project, throughout the life cycle, throughout the sprint, whatever it may be. So this is an example of quality being built in throughout. This is going back to the bank that I was talking about before, and you can see how this is done here. I'll get a spotlight going here. In this example, what you see is that there are 5 projects that are currently in flight. I'm showing them simplified, showing them with a single drop. If they were on an agile life cycle, there would be cycling going on here, and there would be occasional drops, but same kind of activities would be happening. So if you think of the specifications, as I said, the requirements reviews and design reviews, these are mandatory activities, and the independent test team organizes those. So right from the start, we're saying we're going to get defects out of the requirements and design. The development and unit testing, unit testing is mandatory for the developers. I don't remember what their standard is for that, but it's, at the very least, the unit testing has to be done, and I believe there's a code coverage standard that applied as well. Component integration testing here is optional. Project teams could decide whether they need it or not, but if it was to be done, the programmers and the developers, the development test team would work together. They're separate development test teams for each of the projects. So this would be kind of like in an agile approach with a tester embedded in the sprint team. And then there's system testing, which is mandatory. That's prior to any sort of delivery into the system integration test here. And the way the system integration testing works is that every 2 months they have they start testing a new release, and you see they've got a couple environments going here. And so if your code is ready at that point, then you can catch the train, as it were, and then the system integration testing is done by this independent test team. That includes both employees and in-source testers. And there's also a special acceptance, or excuse me, a special security test team that comes in and does the security testing here. And then finally, there's user acceptance testing, which is done by the end users, and those would generally be experts. So you notice that there are a lot of activities from the very beginning to the very end. They're quality focused, and there are a lot of different people participating. So testing and quality are pervasive in the life cycle, and they're pervasive in the team. They're not we let the testers deal with all that quality stuff. Okay, so how about a bad example of what happens when you forget quality until the end? This is just hilarious to me. Some of you might remember this thing, this Apple Newton. Now, in defense of Steve Jobs, I mean, just point out that the Steve Jobs, while he's identified so strongly with Apple and has been there for a while now, and was there at the start, there was a brief period in the middle of Apple's existence where he wasn't there. He was fired by the CEO that he hired, ironically enough. And a number of things kind of didn't go real well for Apple. In fact, when Steve Jobs came back, they had basically been counted out. They were about to be bankrupt or bought up by some other competitor and turned into who knows what. But anyway, during that interim, they produced some products that weren't quite so great, and one of them was this Apple Newton. And the Apple Newton had a handwriting recognition, quote unquote, feature, which is mocked here in this Doonesbury cartoon. This is one of actually a whole series. I think there are probably about a dozen. This was the one that that made me laugh the hardest when I read it just recently while I was putting this presentation together. I hadn't seen these in the, say, 15 or so years since they first came out, but it is absolutely hilarious sequence of cartoons that he did. And of course, you don't want your product being lampooned by a cartoonist. They say you can't. There's no such thing as bad publicity, but I think the people that work on the Newton would be declined to agree with that particular statement. So they got to the market with this thing, and then they thought, oh, this is as Trudeau puts it here, tongue firmly in cheek, an indispensable desktop tool of the future. It didn't work, it cost them untold amounts of money, if you think about it, because this was their entry into the personal digital assistant world, which they then sort of got laughed out of, and you ended up getting, Palm and other organizations that just ruled that until the smartphone came along and basically made the PDA obsolete, or if you prefer, merged the PDA and the phone into one thing. But in that interim of time, prior to that merger happening, there were millions and millions of dollars made selling PDAs, and Apple didn't get any of that money, or they got very little of it, because they hurled this product into the market too early with a piece of software that didn't work, and pretty much doomed the thing. All right. Now, focused, well-managed testing, the next element here to cover. Now, again, I want to emphasize that testing is only a part of the quality strategy. It can't be, testing by itself, but it is a key part. It is an essential part. We've seen plenty of clients that have failed to achieve quality, even though they had a relatively good testing operation. But we've never seen a client that had all the other parts of a quality strategy, a good quality strategy, achieve quality, and didn't have good testing. So it is a necessary component. Now, when I talk about well-managed testing, it's important that testing be seen as something more than this big geeky bug hunt. It is not about, gee, look at all these cool bugs I can find. It's not about wandering around in the product seeing, can I find obscure ways of breaking this? Because yes, finding defects is important, is an objective, but it is only one of the objectives of testing. Certainly, we need to make sure that we are building confidence and reducing risk in our testing, which means that we need to look at the important parts and test what's important. There need to be clearly defined objectives in place, and we have to manage achievement of those objectives and ideally measure the achievement of those objectives. How well does the process work? Just turning loose a crowd of smart people and saying, go find a bunch of bugs, that's not a strategy for long-term success and from a quality point of view. Now, the management of testing doesn't have to do only with the testing, too. It's also the case that when testers find bugs, that smart bug management decisions have to be made. Of what's more important? Which should we fix? What should we defer? Because any one of these sort of decisions about changes to make, including fixing bugs, is of course a change. There's cost, benefit, risk, and opportunity elements that need to be considered. And we've seen clients have problems where they just don't devote enough time and energy to thinking through, how are we going to deal with the bugs that are found by testing, and they get plenty of opportunities to produce a quality product, but those opportunities are missed because the opportunity was presented in the form of a bug report. Now, so let me give you an example of this. What do I mean by not doing the testing right and not focusing on the right things? Well, when we do an assessment, we're typically going to look at how the testing is focused, and so we'll look at defect detection effectiveness, which if you're talking about system test or system integration test at the end, you can calculate that by taking the number of bugs found in testing and dividing that by the number of bugs found in testing plus the number of bugs ultimately found in production. Now, that's your overall defect detection effectiveness, and I mentioned earlier, that about 95% was a really good number there. There's another thing that you can do with this. It's interesting. Is you can say, okay, you know what? I'm going to run the defect detection effectiveness for all the bugs. Do that first, and then filter that so only the high priority or high severity, depending on how you define importance in your bug tracking system. So I look at defect detection effectiveness for the high priority bugs. Now, if we are focused on the right things, we should be more effective at finding the important defects than we are at overall defect detection. Now, interestingly enough, what we typically find is unless an organization is doing risk-based testing, they actually, that inequality will be reversed. That they might have a relatively good defect detection effectiveness, 85, 90%, but if you look at their defect detection effectiveness for the high priority bugs, it's actually not as high. It's less than that. So they're basically squandering their efforts in some sense, or well, not necessarily completely squandering it, but they're diverting some amount of their attention to the wrong things. Now, to present a good example here of what I'm talking about, of focus testing, this is from a testing policy that we helped one of our clients put together, and just kind of illustrate what we've got. We've got different test levels defined here, somewhat like what you saw in the previous diagram, except that this is they're a software selling company. They sell enterprise software, so they have their unit testing, they have component integration testing, they've got system testing, and then they've got system integration testing, and then they've got beta testing. Now, the unit testing is owned by developers, and we have clearly defined objectives here. What we're trying to accomplish: detect bugs, reduce risk. Should be done before component integration testing. Results should be well documented. In component integration testing, here's what the developers are trying to do. Similar things that they're mostly looking at. They're looking at interfaces here now, and it's ensuring development ownership, delivering quality features, so making sure that stuff actually works. The QA team has a role in the component integration testing too. They're validating the completed features, so basically it's like a feature acceptance test that's happening here. And then in system test and system integration test, this is owned by QA. We're trying to detect bugs, reduce risk, and build confidence in various use cases and end-to-end scenarios and user workflows. And then for our beta tests done by the customer, looking for bugs that are customer specific, make sure that the customer's business requirements are met, at least reduce the risk of that, try to make sure that they're trying to demonstrate that we're ready for deployment to the wider world. So, these are all clearly defined objectives, clearly defined owners, clearly defined levels. This is how testing can be, or one example of the way testing can be managed in a focused fashion. Now, sending the right message. This is another important element of quality, building quality systems, making sure that everybody understands this is what we're trying to do. This is why quality matters. This is what we can and should do to achieve quality. How we're going to look at how we're going to achieve a balance. And this is again about management messaging. Talk about quality, but also talk about how it's going to be achieved in in a balance. Can't just say, run around with platitudes like quality is job one. Well, okay, really, quality is job one. What exactly does that mean to me in terms of making decisions in tricky situations where there's multiple paths forward, and each of those paths optimizes budget, feature, schedule, and quality mix differently. So you've got to be clear about the message of quality matters, and also you got to be not undermining the message with perverse incentives, giving people bonuses or doing their performance evaluations in such a way that says, well, yeah, quality matters, except that what actually determines how much you get paid or how big your raise is on time and within budget. And as long as there's not an outright quality disaster, then nothing bad will happen to you. Well, at that point, it doesn't matter what's said to people, what kind of message management is putting out. What people will hear is what money is saying to them. Basically, money is saying to them, focus on budget and schedule. So you have to avoid that too. You could be saying all the right things, but then undercutting it with the actions, if you will. So don't just listen to what people say. Watch what they do, right? And if people are talking about quality in the right way, with the right focus on it, not as some sort of idealized thing, but something practical and true that can be accomplished, and you see them doing work to actually carry that out, then you can say, okay, the message is getting through here. So maybe a negative example here of stuff that we've run into, or examples in this regard. Excuse me. On one assessment, well, a number of assessments we've done this, but on one particular assessment, we ask, okay, in terms of priorities, rank quality, schedule, budget, and features. In other words, which of these things is the highest importance? It's least likely to be traded off in a given situation where it's in conflict with the others, and which of these is most likely to be traded off. And what we heard back from line management and from individual contributors was exactly the same message. Schedule is always first, followed by budget, because it's virtually impossible. It is impossible to change the schedule. It's virtually impossible to get more money or people. Features is number 3, and quality is last. Okay. All right. Well, you could define that as the right priorities, I suppose, if you wanted to in an organization. But here's where the disconnect is. We go to senior management, asking senior management, what's the trade-off here, and they're like, no, quality is always first. Quality is the most important thing. But then it would turn out that they didn't want to give up any of this other stuff either, right? And since quality was like the squishy part that wasn't really well measured, guess what? That's the one that got given up. That's what gets measured gets done, and what doesn't get measured doesn't get done. So by not having measurements in place that could basically collectively hold the project teams accountable for the quality that was being produced, while they did have measurement in place for the schedule, feature, and budget elements, they were sending management was sending a message. What we're caring about is what we're measuring. So the message wasn't getting through because it was being undermined by, as I said, the perverse incentives created, in this case, by the measurement system. Another example, different assessment, different group. We asked the non-testing people question, what's the value of testing? And the answer uniformly was testing has no value. And they weren't talking about testing in general. They were talking about testing as specifically done by that group in that organization. So we asked the test staff, well, what role do the other teams play in quality? And the answer was pretty much uniformly, oh, they're lazy, they don't care about quality. So here obviously the wrong message is being sent from management and between the teams and so forth. And of course they're not working together to achieve a quality outcome. They're not working together at all. Basically, they're at each other's throats. This organization, they ended up outsourcing pretty much all of their testing about 6 months after our assessment, just because they kind of threw up their hands and they couldn't get anyone to collaborate to make things better. Now, don't want to have a depressing example only there. This is an example of things done well, where quality was indeed everybody's job. So this is an assessment where I was talking to testers and programmers, and these guys are following an agile approach. And I would talk to the programmers about, well, what kind of unit testing you're doing, what kind of static analysis you're doing. All told enthusiastic stories about stuff they were looking at and using, and how it was working for them. And really sincere, earnest kind of guys, are really guys and girls working very hard to do great work. And one of them made an interesting comment to me, which is something that's very heartening to hear. This programmer, and again, this is like totally sincere. This guy wasn't just like putting this on, or okay, I'm going to spin the consultant with this. He was, in the middle of talking about all the stuff he was doing with these open source tools, and he was really enthused, and said, we spend a lot of time around here just talking about how to write better quality code. And I was thinking, wow, well, that's a huge thing, because there you go. You got the message has been sent from down all the way to the individual contributors that's an important thing to do. Spend your time talking about how to write good quality code. Do good work and good things will happen. That was the message that this organization was sending out, and they were sending it out pretty consistently across the organization, and it was working. They were doing good work. They were collaborating, testers and developers working together, looking at how to achieve higher levels of quality. So it's really a very heartening kind of experience in terms of that assessment. So yeah, it can be done. It is done. Now, before I wind this down, I want to just say, five things. They don't necessarily sound complicated, the 5 elements, but it requires a great deal of discipline, and it isn't easy, and there's no sort of magic pill that you're going to take that's going to make this happen. We've seen these elements in place in organizations that are following sequential life cycles, and they're working there. We've seen these elements in place where people are following agile life cycles, and they're working there. We've seen these elements missing in agile and sequential life cycles, and guess what? It doesn't matter whether you're agile or not. When these important elements are missing, then bad things happen. So, I think we need to get out of, as an industry, this mental model that some people have fallen into of, well, if we just adopt the right life cycle, then everything's going to be great. Life cycles help, but be careful of people making money pushing life cycle solutions and tools that support life cycle solutions that are saying this is going to solve all of our problems, because we've seen this movie before in software engineering like a bunch of times. There's 4th generation languages and object-oriented programming and on and on and on. Structured programming is time and again people have purported that they were going to solve the quality crisis in software, and nothing has. So there's no magic solution to it. There's just hard work. New languages, new platforms, those have made it easier to get stuff to market. That's true, but quality, not necessarily changed. It's a matter of behaviors on projects, not technologies and platforms. Now, excuses. You hear excuses about, well, with this, that, and the other thing made it impossible for us to deliver good quality, and I'm sure the people in the Newton project had great excuses for why things went the way they did. But important to remember, an excuse is a very poor substitute for success. Which would you rather have, a success or an excuse? And of course, whenever somebody doesn't have a success, they immediately go for having an excuse, but it's not a real good substitute. Now, these things that I've been talking about here, these 5 elements of quality, you've probably been thinking, these are like good ideas that have been around a long time, and yeah, I think that's definitely true. I mean, what we know and what we have known for a good 20 years or so, and what we do in the software engineering industry are not always the same, but sometimes they are. These best practices that are proven themselves over the years. Where people have the discipline to instill them and to follow them, they get results. And where people follow fads and so forth and don't pay attention to what's proven to work, then of course there are problems. Okay, so to recap the five elements here for managing quality within constraints. Again, the balance is quality with features, budget, and schedule. What we need are the 5 things: the shared vision of what the product should be, disciplined approach to management, a way of building quality in and getting bugs out throughout the software lifecycle, focused form of testing, looking at particular things, focusing on particular things, and as I said before, getting the right message out to the right people. So in my career as a tester, test manager, and consultant, I've seen plenty of successes where these elements were present, and plenty of failures when they were not observed. So they are long-term observations here, not just flavor of the month. Now, as a test person, sometimes we're tempted to say, well, I'm here to be sort of the champion of quality, the advocate for quality. And I'd actually suggest that you, if that is your perspective, if you think of yourself as the quality cop, that you try to change that mindset. I haven't seen that be particularly effective. What's effective is to advocate smart ways of achieving a balance in terms of quality, schedule, budget, and features. Some sort of conscious, careful, mature fashion. So don't say no, you can't do that because it's going to result in this bad quality outcome. Say, well, okay, here are the things that we can do on this project, and for your given situation, here's the pros and cons from a quality point of view. Here's what I would recommend. But trying to be a quality cop is not something that I've seen successful. But what does work is disciplined, long-term approach to putting these elements in action and sticking with it, including when times are tough and when the project is in trouble. Okay, so that's includes the presentation proper. Put the advertisement up here as usual, and get the Q&A bar out and about here. Let's see, give me a moment to get this set up. Okay. So I got a question from Jay Ellison. What is meant by the term robust in bullet 3? Well, let's see where we're. Let's see. You asked that question about 113, and I'm not sure exactly where I was in the robust. Let's see if we can find that. Robust. Okay. Plans and estimates. Robust and realistic. Okay, so robust, Jay, what I mean is that they have built into them mitigation and contingency plans for project risks. Now, a project risk is something that could go wrong that would interfere with your ability to carry out the project successfully. And of course, every project has project risks, and there should be a process in place for managing those project risks, so that when those project risks become realities, and some of them will, that those don't manage to single-handedly derail the project. Let's see, got a question from Rich. Good to see you back, Rich. Let's see. As I manage performance testing from a service model, I know the industry has turned to the utility model or the as a service to resolve the how to manage quality within budget and schedule constraints. Does billing for units consumed eliminate these trade-offs or merely simplify them from the client view? Well, we can buy testing as a service, but that's not the same as buying quality as a service, right? You can't yet go out to a vendor and say, how much do I have to pay you for defect density of X and a mean time between failure of Y and an annual number of reported field failures less than or equal to Z, and you can't do that yet. And I can't see how that could actually be done or anything even approaching that. So, Rich, I think what happens when you're purchasing testing services is that they're often making the trade-offs, as you say, simpler to at least simpler to see. I think you're going to have to pay this amount of money to get this amount of testing service becomes more clear. But quality outcome, that's still something that has to be managed separately. And in fact, I'm working with a client at a conference call later this afternoon to talk about how to put SLAs in place on an agreement with a vendors that will be providing testing services, and it's tricky because you got to measure the service, but how do you got to also detach that from the outcome, the quality outcome, because the testing by itself can't do it. Let's see. I got a question from Steve here. What is the testing process called in which a developer reviews code paths and predicts whether a particular change might create regressions that are outside the scope of the particular change being made? Well, that would be impact analysis. Are there tools or workflows for that a very small development shop could take advantage of? Boy, impact analysis. Well, so there are some tools that can help with that to some extent. So if you have you have traceability of requirement specifications and design specifications to the tests and also to each other, if you've got architecture diagrams and those sort of things, then those can be utilized to try to figure out where is regression likely to happen. The problem with a lot of impact analysis that's code focused is that it's done typically by the developer who did the programming themselves, and the difficulty is that the programmer's going through and they're like, okay, well, what might have been broken by this change? But if they could predict accurately what was going to be broken by the change, I mean, wouldn't they just not break it? So, and any sort of tool that supports this, I think, is likely to suffer from similar problems, as it can't know what it doesn't know. So I'm not familiar with a lot other than just sort of this, trying to use traceability and architecture diagrams and the best guess of the developer to try to figure out what to do in these situations. Now, part of it is worth mentioning that there's an intrinsic code quality element of this too. That the more maintainable the code, the less coupling and more cohesion we have in the code, the lower the complexity we have in the code, the less likely regressions are. So Proclivity to regress is often an indicator of code quality problems, and that is actually something that can be sniffed out with some tools. So if you've got reasonably good defect data, you can look for bug clusters by basically looking for the percentage of defects associated with particular modules. Sometimes that needs to be normalized by the size of the modules in terms of function points or lines of code or what have you, but that's something that can be done. And then you can also use static analysis tools and cyclomatic complexity metrics to try to figure out where the code is unmaintainable as well. And that can be a good way of attacking the regression problem proactively. Like, rather than let's spend a lot of energy trying to make our regression test suite bulletproof, which is really sort of a fool's errand anyway, because for any large collection of code that just becomes an enormous thing. Instead of trying to come up with the perfect bulletproof, inescapable regression test suite, then how about focusing a similar amount of energy on reducing the likelihood of regression to begin with. Now, I'm not saying don't do regression testing by all means. I'm just saying that sometimes there's a lot of energy put into the testing bugs outside of the quality equation, where that same investment of energy, if it were made in the building quality in part of the equation, would pay off more. A comment from Tracy here. Thank you for your time, Rex. Always interesting and insightful. Thank you for that, Tracy. Glad you are back. Geetha asks, what is the best practice to make the management team understand the balance? Right now in our company, schedule is the highest priority as the features were promised to the company or to the customers. Thank you once again for a great presentation. Well, Geetha, let's see. It's very hard to make people understand something. I mean, they have to want to understand first, and then they can be brought to understanding. But it's hard to push management discipline up, I guess. So I was talking about discipline management. I mean, that's something that goes towards the top. So it's if managers are just saying nope, we got to have this right now, and these features have to be delivered, and they have to be delivered with quality, and there's any discussion of the balance just gets shot down as that's defeatism, or that's you're just making excuses. There's really not much you can do in those situations. I remember years ago working in an organization like that where one of the project managers, who was a very good guy, very diligent, went on to be quite successful in another company later. Well, this project manager came back with a estimate for how long it was going to take to create a set of features, and the marketing person on the other side of the discussion was like, well, it shouldn't take that long. You should be able to do it in half that time. He said, look, I just can't do it in half that time. This is how long it's going to take. And the guy said, no, you're going to create those features, and here's how long you've got to do it, period. And he said, well, look, you can say what you want in terms of what the schedule's going to be, but what I'm telling you is that this is when those things are going to be complete, because this is what our capability is. And the guy came back, and it was unbelievable. He said, well, I don't believe you at all. I think that you actually could get them done within the time that I'm asking you to do it, but now you're going to drag your feet and make it take longer so that it finishes when you predicted, just so you can say to me, I told you so. I don't understand how can you have, you can't make someone like that understand something, right? I mean, because that person's just bound and determined not to listen. There's zero trust or credibility between those two people, apparently, at least on the marketing side of the fence. So it's going to be very difficult in a situation like that to bring people to understanding. I mean, we've seen sometimes you get sort of the crisis brings people to understanding. It's some sort of quality or customer disaster, but that's sometimes lessons learned that way they don't always stick too. So it's a tough road, Geetha. I mean, it's just do what you can. As I said, the process cop or quality cop thing will not work in my opinion in any situation, but it certainly does not work in this kind of situation. If you're getting all sorts of unreasonable pressures and you decide, okay, well, I'm just going to start talking about best practices this and quality is job one that and obstructing, and you just that's not likely to work out well. Let's see, Tom's got a question here. How do you feel about doing system testing throughout the life cycle? We were trying to do that type of testing in hopes of finding workflow, robustness, etc. problems early on. Well, I mean, if you're in a iterative type of life cycle, then certainly that would make sense to do that kind of thing, to have sort of continuous system testing happening. In a sequential life cycle, I think that's a little harder to do, Tom, because the maturity of the product might be such that there's simply a lot of tests that you can't do. There's just nothing. There's no capability there to do them. But if you can, yeah, I mean, getting testing started in important areas as early as possible is a good idea for sure. Let's see. Some questions from Jay about the earlier parts of the presentation. I'll just point out again, these are recorded. These presentations, they are recorded, and they will be posted here within the next couple days. So if you missed anything, then feel free to check out the recorded version. Let's see, Lisa Marie. Hey, how you doing, Lisa? Got a question here. What are the pitfalls of test management using performance review objectives as a way to control testing? Oh boy, a presentation in itself. It is very difficult to set performance goals for people that are tied to process outcomes, and this is true of any process, including the test process. It's difficult to set performance goals for people that are tied to process outcomes that do not have unintended side effects, unintended consequences that occur. It just I've seen it over and over again where that happens. So you really want to not go that route. I mean, it's that you want to set goals for people absolutely as part of their performance evaluations, but this is really, they need to be sort of longer term types of things about how people are doing and are they building their skills and so forth. Now, I think it's fine to have, in fact, you should have defined objectives for testing groups with metrics for those objectives and goals for those metrics. But that's different than saying I'm going to reward and punish people financially based on how the test process is going, because there's just too many other things that are involved. Let's see. So James has a question here about the rectangle thing. This guy here. Is in the rectangle where features are defined, schedule, cost, and quality form the triangle. Does that mean does that mean those are the features that will not get done? How do the lines of the triangle relate? Is X, Y, time, and dollars not exactly clear? Since it would be a powerful communication tool if I could fully explain it. Okay, let me see if I can make this a little more clear here. There's not a measurement to this. Okay, so let me just shrink the size of this Q&A dialog box here and get the highlighter up. So what I'm saying in this is that, okay, I define a set of features. Okay, that's what this is. It's defining the features. Now, I'm not trying to say the bigger the box, the larger the set of features. The smaller the box, the smaller the set of features. I'm just saying we define a set of features, and that basically puts a bounding box around the project, right? The project is to create this set of features, okay? And then inside that box, we start putting the other elements of the project, the first of which is often the schedule, the delivery date. The delivery date is set. Sometimes the features and delivery date are set at the same time because the customer is saying, I will pay you this amount of money to get this particular set of features to me on this particular date. But anyway, the schedule is set. So the schedule, I'm just drawing in the line here. I'm not saying, longer line means longer schedule, shorter line means shorter schedule. I'm just saying draw a line that represents the act of setting the schedule, okay? And then with cost, okay, now the budget, comes next. Here's how much we're going to spend. So draw another line connected to the first line at one end or the other, either end. Draw a line that goes from one end or the other of the schedule line and ends at one of the opposite walls, one of the walls not touched by the schedule line. Okay, so this line here. Again, the length of the line, I'm not trying to make any sort of illusion about longer line needs more money, shorter line means less money. It's just, okay, you draw a line, all right, and it has the property that it starts at one end of the schedule line and it ends at a wall which is not touched by the schedule line in that box. And then what I'm saying here is that by doing that, we have now constrained the features, we've constrained the schedule, we've constrained the cost. There is only one way to connect the two lines of schedule and cost at the not touching ends. That's the quality that you're going to get. Basically, what I'm saying is that line, we draw that line to represent quality, and that's representing the constraint of quality by those other three variables. And what I'm trying to do here is I came up with this as a way of trying to push back against what sometimes gets called in project management circles the triple constraint: feature, schedule, and budget. And I'm trying to say, no, it's not triple, it's four. There are four things here. And I think part of this comes from people get confused about quality, right? And they don't have a clear definition of quality as the fitness for purpose, as Duran put it, and the presence of the attributes that will satisfy the customer and the absence of attributes that will dissatisfy the customer. They tend to think of quality as somehow intrinsically bound up with the features, which is just wrong. It's a separate thing. It's an attribute of the system as a whole, as well as being an attribute of individual features. And as I said, your software engineering process has a certain capability in terms of the quality that will be delivered. And if you constrain, if you set feature, schedule, and budget, then the quality that you're going to get out of that process is predetermined. And which is why you get just sort of the same things happening over and over again, because you're doing it over and over again, right? Now, again, the process can get better. As I said when I was initially going through these slides, the process can get better, and the quality capability can go up. But that has to be deliberate process change for that. It can't just be project managers sit down at the beginning of the project and say, wow, I really wish we do a better job on this project, and then everybody goes off and does exactly the same thing that they always do, and of course they get exactly the same outcome, right? That's not an approach to achieving better quality. Hopefully that made that a little more clear, James. Let's see. Let's see. Michelle asks, is there a good number to target for a DDE, defect detection effectiveness metric? Yeah, absolutely. I'd say if you're first benchmarking yourself, then I would encourage you to say, look to see if you're at 85%. Are you above or below? Because if you're above 85%, you're above average for an independent test team. If you're below, you're a little below average. Where do you want to be eventually? Well, it kind of depends on what the aspirations of your organization are. But certainly, I think getting to the mid 90s is a good place to want to go. In some organizations, your mission critical applications or safety critical software, of course, you should probably be higher in the 99-ish%. Marilyn asks, regarding the constraints between defined feature, schedule, cost, and quality, what about management solution to add additional, although often not very experienced, testing staff when there is a concern about making the date? Oh boy, you've lived that nightmare too, huh, Marilyn? Yeah. This is tied to the anyone can test misconception. I'm actually going to I'm doing a presentation in Moscow at the end of March where I'm talking about the difference between test management and quality management. And this is one of those signs of confusion that you see of people think that, well, anybody can test and all we've got to do is test and that'll give us quality by magic. Yeah, you really have to try to explain that testing is a skilled activity, and just throwing a bunch of people that have no clue as to what they're doing at testing to try to speed it up is as likely to slow it down as anything else. Now, let's say in testing you have to play the hand you're dealt. So let's say, okay, you are stuck with those people. There are ways to try to organize that to get better benefit out of them. Basically, it involves doing, understanding what adequate test scripting would be and dividing up the work amongst those people in such a way that they actually are doing some amount of confidence building in terms of what they're testing. Their defect detection effectiveness tends to be kind of limited. Let's see. Sanjay asks, will a recorded version be available later? And Sanjay, yes, the recorded version will be posted, and you will be able to get the PDU information out of that as you ask. I just want to point out once again that the PDUs are only available for live attendance. So recorded, if people are just listening to the recorded version, if you're just listening to this recorded version now, and thinking, oh, I'm going to apply for PDUs. No, that's not okay. It's not allowed. If you don't like that policy, you'd have to take it up with PMI, I'm afraid. Let's see. So David says, I think in PMI speak, the triple constraints now has 6 parameters, including quality, risk, and stakeholder satisfaction. Cool. Okay, now I'm good with that, because now I think those are good. Now, sure, I'd have to think a little bit about the risk and stakeholders as trade-offs against those, or stakeholder satisfaction as trade-offs against those, but food for thought. Thanks. Let's see. So John says, Rex, we are starting agile development process on our first project next month. Management has already asked how we are handling the risks associated with starting a new process. Specifically, you expect to shorten system test time due to the expected gains through better quality code in the sprints. They suggested that we add in sprints with not new features, that is, add in time. Any good inputs on how to handle this question from management? So I think, John, what you're talking about is what's sometimes referred to as a stabilization sprint, periodic stabilization sprint, which is where you add features in some number of sprints, and then you sort of take a break and say, okay, we're going to have a sprint that's focused 100% on dealing with what's sometimes referred to as technical debt, which is backlogged bugs, if any, design issues that have crept up over time because of, as often Agile is often very weak from a design point of view, so there might be some significant refactoring and so forth. Yeah, we've seen clients do that, stabilization sprints, and that does seem to work pretty well. I think it might be useful for you. I've got it. There's a couple recorded webinars, one on Agile testing challenges and another on Agile testing opportunities that are posted on the digital library. So I'd say go take a look at those and see if those are helpful. So we've got through most of the questions. We've reached the end of the time. Let's see. Is there any last ones? I got a question from Ken, and I'll try to answer very quickly. Do you feel it difficult to test every requirement that is specified? How does that affect the process of defining requirements? Or do you find it difficult to test every requirement that is specified? Well, I would say, Ken, that if you're in a situation where you do not have adequate time and resource to even run a single test for every requirement that's being specified, you're a seriously under-resourced organization, I would guess. Now, I'd have to know more about your situation, but that seems to me is like the absolute bare minimum of what could be covered in testing is that every specified requirement has at least one test associated with it, and I mean, if you're not doing that, you're building code with no intention of testing it, then that's not good. Okay, so to close this session, a little bit more about the RBCS resources quickly here, and given the constraints of time. These free webinars run once a month, so check the website, rbcs-us.com, to sign up. If you want a special webinar presentation internally, send an email to info@rbcs-us.com, and we can set something up for your organization. If you don't get our free newsletter, sign up at rbcs-us.com. This gets you valuable discounts on our services and a regular newsletter with featured articles and news about what we're doing. Follow us on Twitter. We are at RBCS, and also we're on Facebook, RBCS-INC. Do check your email over the next couple days. You could be the lucky winner of a free e-learning course. You registered simply by attending. Check out and comment on my blog. That's rbcs-us.com/blog. If there's a topic you want to discuss on the blog, send email to info@rbcs-us.com with the word blog in the subject line. And check out the digital library. We've got recordings of these webinars, podcasts, and videos out there. You can subscribe to the podcasts in iTunes by entering RBCS Podcast in the search string of the store. And you can subscribe to us on the RBCS channel at YouTube if you want to see the recorded webinars. Again, we offer these free resources as a service to the software testing community because at RBCS we are a not just for profit company. This concludes the webinar. Thanks to everyone for joining us, and see you next month.